Hello, in the two previous walkthroughs we created the design of a touchscreen sensor of a smartphone. Then we continued by setting up and running the simulation of our design. In this walkthrough, we will show you how to analyze the simulation results we have received for resistance and mainly capacitance. We will also use their trends to get useful information, especially regarding the compatibility of the design with a particular controller. Resistance results are here for the 3 electrode cells as we selected. From there, we can easily calculate the cell resistances of each electrode. In this case, they are 97.3 ohm per cell for Y electrode and 114 ohm per cell for X electrode. To calculate the total resistance of each electrode, we multiply the cell resistance with the number of electrodes. Since we have 27 Y electrode cells, the total resistance of each Y electrode is 2.628 kilo-ohm. Similarly, for 15 X electrode cells, the total resistance of each X electrode is 1.71 kilo-ohm. We can also see the capacitance values without pointer and for every pointer position inside the capacitance maps. Through the map, we can see the mutual capacitance C1 and the self-capacitance of both electrodes of the selected node C2 and C3. We also observe the reduction of the mutual capacitance delta C1 when the finger is present. This reduction was expected, as the finger, when close enough to an electrode node, reduces the coupling effect between the electrodes of the node. Finally, we see sensitivity, that is, the ratio of the delta mutual capacitance to the mutual capacitance when no pointer is present. We can compare capacitance values between the 3 projects for each pointer position too. Let us focus on mutual capacitance C1. This way, we can see how those 3 areas of the touchscreen sensor respond differently under the presence of a pointer. Analyzing our capacitance results, for example, we can observe that when we slide the pointer away from the center of the cell area, mutual capacitance increases, while delta values of mutual capacitance and those of sensitivity both reduce. This is expected, as the pointer has a reduced effect upon the electrodes as it moves away from the electrode's overlapping area. We also observe that the self-capacitance values reach their maximum when a pointer approaches the center of a diamond. This too is expected, as, at this area, the coupling between our pointer and the respective electrode is higher. Sense allows us to do a quick check regarding controller compatibility with our design if we know some of the controller's specs. Apart from the controllers that are included in Sense's library, we can create a new controller for our project. We type a name for our controller, and then we select 32X and 16Y pins so that it can support our design. We select a minimum capacitance of 0.05 picofarad and a maximum capacitance of 1 picofarad. Finally, we select a sensitivity of 0.05 picofarads. We can check now if this controller can support our design regarding the range of capacitance and sensitivity values of our touchscreen sensor. We also observe from values of delta of mutual capacitance that there are some undetectable points inside the cell area. The results sections of Sense can be very useful for a quick evaluation of our results. We can also export the datasheet with the simulation results if we need to further analyze them. To do this, we simply click here. Here we can see our various design parameters as well as all the simulation results. We can combine those simulation results and focus on the specific aspects we want to. One example is what we have already done here for the variation of delta of mutual capacitance with finger movement along y-axis of each node. Here, it is clear that there is a consistently declining trend on all nodes as the finger moves away from the center of the cell area. With the Export as PDF option, a report will be automatically created that includes inputs, images, design characteristics, simulation analysis, and results. We are now done. We went through the capacitance and resistance results, made a quick analysis of them, and then analyzed their trends. We also checked the compatibility of our design with a particular controller, exported data sheet with our results for further analysis, and finally created a report of our design. Due to our design being symmetrical, we can now expand those results we got through simulation over all the individual areas of our smartphone touchscreen. In the following walkthrough, number 4, we will show how we can use these results with the help of a SPICE simulator so as to further evaluate our design regarding charge time. So, thank you for watching, and stay tuned for more to come soon.